Hello friends, you are welcome to another interesting video on this channel. In today's video, we are going to look at pH and pOH calculation. More especially how you can calculate the pH and pOH of various substances and solutions without a calculator. As you all know that the JAM calculator does not have the function of logarithm and antilog, and we expect to calculate questions or solve questions on pH and pOH without a calculator. So let's get started. So before we look at the calculation aspect, we have to understand what pH and pOH means, and we have to look at various formulas that will help us in calculating the pH and the pOH of various substances. So what's the pH? pH is called the potential hydrogening, or in English language it means the power of hydrogen. The power of hydrogen, or it's simply a measure of the acidity or alkalinity of a solution. So pH simply tells us if a substance is acidic, if a substance is alkaline, or if a substance is neutral. We'll look at the pH scale very soon, which will tell us the ranges of values that can tell us if a substance is acidic, if a substance is basic, or if a substance is neutral. So in pH, we are looking at how acidic or how basic a solution or a substance is. But mathematically, we define pH as the negative logarithm to the base 10 of the hydrogen ion concentration. So that definition gives us the formula for calculating the pH of substances. So we have this, we have it as pH as the negative logarithm. pH, which is written like this, p to the power of h, is equal to the negative logarithm, that's logarithm to the base 10, which is your natural log, to the base 10 of the hydrogen ion concentration. So to the concentration of what? The hydrogen ion. So in essence, pH is defined as a negative logarithm to the base 10 of the hydrogen ion concentration. So in chemistry, this parenthesis signifies or it stands for concentration. So on the other hand, we have pOH. pOH is defined as a negative logarithm. So we have p to the power of OH. It is defined as a negative logarithm, to the base 10, which is our natural log of the hydrogen ion concentration. When I talk about natural log, it's also called log 10. So in mathematics, you can choose to write that 10, or you can choose to do away with the 10. So, but just know that yes, the base 10 here. So it is the negative logarithm to the base 10, though not indicated here, of the hydroxyl ion. Hydroxyl ion is presented in chemistry as OH minus to the hydroxyl ion concentration. So in essence, we have pH as the negative logarithm of the concentration of hydrogen, and pH as the negative logarithm of the hydroxyl ion concentration. So for calculation purpose, we have these four formulas. Recall that the pH is defined as the negative logarithm of the hydrogen ion concentration. Also, the pOH is the negative logarithm of the hydroxyl ion concentration. Also, you should know that the pH of a substance plus the pOH of that same substance is equal to 14. And also, you should know that pH has no unit. So we can calculate and get an answer of 1, 2, 3, or 4 without a unit. So it has no unit. Also, the hydrogen ion concentration times the hydroxyl ion concentration is equal to 1 times 10 raised to the power of minus 14 mole square per dm raised to the power of 6. So the next concept to look at is the concept of the pH scale. The pH scale is simply a reading that tells us if a substance is acidic, if a substance is basic, or if a substance is neutral. So our pH scale has a reading that ranges from 1 to 14. So we cannot have a value greater than 14, and we cannot have a value lesser than 1. So our pH value must range from 1 to 14. Also, you should know that when a substance has a pH of 7, we can say that that substance is neutral. And moving towards this side, the substance tends to become alkaline or tends to become basic. And moving towards this side, the substance tends to become more acidic. Hence, we can say that 1 is the most acidic and 14 is the most alkaline or the most basic. So if we have values between 2 and 3, we can say that 3 is more alkaline, but 2 is more acidic, because moving towards this side, the substance tends to become more acidic, and moving towards this side, the substance tends to become more alkaline or basic. And at 7, we have a neutral substance. So let's get started with the calculation aspect under pH and pH. So we are going to look at how to calculate pH and pH without a calculator. Recall that the JAM calculator lacks functions like logarithm and anti-log, and you should be able to calculate for the pH and pH using the functions of log without a calculation. For this reason, you have to master the log values from 1 to log 10. You have to know what the values of log 1 down to log 10 are. So in this question, we have a question which says calculate the pH of a substance with an hydrogen ion concentration of 1 times 10 to the power of minus 14. So the question says to calculate the pH, and we are given an hydrogen ion concentration of 1 times 10 to the power of minus 4 mole per dm cube. So we have our hydrogen ion concentration as 1 times 10 to the power of minus 4 mole per dm cube, and we are told to look for the pH of the substance. So recall that the pH is equal to the negative logarithm of the hydrogen ion concentration. So we can write 1 times 10 to the power of minus 4 as 10 raised to the power of minus 4, because anything times 1 is that same thing. So therefore the pH is equal to negative logarithm. Our hydrogen ion concentration is the same thing as 10 raised to the power of minus 4. So in your exam, how can you solve this without a calculator? A particular law in logarithm says that log x raised to power a can be written as a log x. What does it mean? It means that I can take this power to the back and write as a log x. So if I have log 2 raised to the power of 3, I can write this as 3 log 2. So in essence, I can calculate this as pH to be equals to, I will take this minus 4 to the back, becomes minus 4 log 10, because I've simply taken this power minus 4 to the back. It's now written as, there's a minus here, then minus 4 coming here, log 10. Now minus times minus is plus, so we have a positive 4, and log 10 from our values is 1. So it becomes 4 times 1, so therefore the pH result is equal to 4. So in our second question, we are told to calculate the pH of a substance with an hydrogen ion concentration of 2 times 10 to the power of minus 4. So remember that our formula for pH is the negative logarithm of the hydrogen ion concentration. So it simply means that the pH is equal to the negative log. Our hydrogen ion concentration in this question is 2 times 10 raised to the power of minus 4 mole per dm cube. So in this question, we are faced with a challenge because this is no longer 1, but this is 2. We can multiply 2 times 10. We are going to go back to logarithm, and there is a particular law that says that log A times B is equal to log times A will give us log A, and in logarithm, multiplication becomes addition. A plus log times B will give us log B. We are simply going to apply this law in solving this question. So I can write this as minus log times 2 give us minus log 2. This time becomes addition. Minus log times 10 to the power of 4 becomes minus log 10 raised to the power of minus 4. So it's simple. Log times A will give us log A, and times becomes addition. Log times B will give us log B. So a singular thing we are going to apply, minus log 2 times becomes plus minus log times 10 to the power of 4. We have this. So we can therefore solve this as pH is equal to minus, now log 2, and simply get log 2 from these values we have memorized, and log 2 is 0.3. So we have log 2 as 0.3, plus minus is minus. Recall that in our previous question, we said we can simply take this power to the back. So we have this as minus 4 log 10. Remember, plus minus is minus. Then taking this minus 4 to the back, we have minus 4, and we are left with what? Log 10. So therefore, the pH is equal to minus 0.3. Minus times minus is equal to plus. This is 4, and log 10 is 1. So when we subtract minus 0.3 plus 4, our pH is equal to 3.7. So in our third question, we are given the concentration of H2SO4 as 0.01 mole per dm, but we are told to calculate the pH of H2SO4. Recall that the pH is equal to the negative logarithm of the hydrogen ion concentration. But in this question, we are not giving the hydrogen ion concentration, rather we are giving the concentration of the acid itself. So we have to find the concentration of hydrogen in this acid, then we can now use that value to get the pH. So what are we going to do? We are given an acid, H2SO4 tetraosulfate 6 acid. So we are going to ionize that acid. So we can write H2SO4. In ionization, we achieve 2 hydrogen ion plus SO4 2 minus. So we see that it's balanced because we have 2 hydrogen and we have 2 hydrogen, 1 sulfur, 4 hydrogen, and then 4 hydrogen. So we have 1 mole of this acid giving us 2 mole of hydrogen ion, which we are interested in. And we are given 0.01 mole per dm of the acid. So we have 0.01 molarity of the acid. It will give us an unknown value, let's say x. So we can cross multiply. By cross multiplication, we have 1 times x to give us x, and 0.01 times 2 give us 0.02 mole per dm cube of hydrogen ion. So in this question, we have been able to calculate the concentration of hydrogen ion present in the acid. So we are going to use 0.02 to solve, because this is the concentration of hydrogen, but we cannot use 0.01 to solve because this is the concentration of the acid, and we need the concentration of the hydrogen ion to solve for our pH in this particular question. So from calculation, we are able to calculate the hydrogen ion concentration as 0.02 mole per dm cube. We can write this in standard form as 2 times, because we move our decimal point, 2 times, we have something as this, 1, 2. So we can write this as 2 times 10 raised to the power of minus 2 mole per dm cube. So we can calculate our pH now as negative logarithm of the hydrogen ion concentration, which is this, 2 times 10 to the power of minus 2. So therefore the pH is equal to, remember the second law of logarithm we took, we can take that as minus log times, so we have minus log 2 times becomes addition, then minus log of 10 raised to the power of minus 2. So we have this as minus log 2 from our values is 0.3, plus minus will give us minus, then we take this minus 2, we can take this minus 2 to the back, this minus 2 to the back, then we have it as minus 2 log 10, we are left with 10 here. So this becomes pH is equal to minus 0.3, minus times minus give us plus 2, and log 10 is 1. So when we subtract minus 0.3 from 2, our final answer becomes 1.7. Therefore, the pH of this substance is 1.7. So friends, I hope you learned something from this video. Don't forget to like this video. Also, do well to drop your questions and suggestions in the comment section of this video. If you are new to this channel, don't forget to subscribe to this channel and also click on the notification icon so that whenever I release any video, you always get informed. Till I see you in the second part of the video on pH and pOH calculations without a calculator, do have a wonderful time.